Hello and welcome. This is going to be our homework help video for the systems review. Let's go ahead and get started with problem number 1 here. Problem number 1 asks us to solve the system by graphing. So what we're going to do is we're going to graph these equations separately, and then we're going to see if they intersect. Because the first line will represent all of the solutions to the first equation, the second line will represent all of the solutions to the second equation, and if they intersect, then that will be a point that makes both of the equations true at the same time. So let's review how to graph. You always start at the end. You start with the b value, y equals mx plus b, and this tells you the y-intercept. So I see I've got a -2, so I go and I put a point at -2 on the y-axis. Now the slope is the coefficient on x. So 1 over 4, this means I need to go up 1, right 4. But I could also reverse that and stay on a straight line by going down 1, left 4. I would still be a positive 1/4 because it's still from this point to this point going up 1 and right 4. Alright, let's go ahead and connect these points up with a solid line. Just about like that. Although, the line's important, it's probably going to be one of these 3 points where they're going to intersect, if they're going to intersect at all. Okay, next one, -x plus 3, so point at 3. Negative x, that's a -1 or -1 over 1. So that means down 1, right 1. It's good to just kind of memorize what a -1 slope looks like, so you don't have to think about it too hard. And then stay on this line going up this way, but going up 1, left 1. And we see we do have a point of intersection. So we'll finish making this line. We will circle that point where they intersect. Now we have to name that point. That point right there, it's 4 to the right of the origin and 1 down. So that is 4, -1. All right, so x equals 4, y equals -1. That's a combination that will make both of these equations work. Okay, number 2. Let's see, y-intercept of 3. I can't go up 4, right 3, so I have to go down 4, left 3 to stay on this line. There's only 2 points that fit. Alright, next line, y-intercept of -3. Go down 2, right 3, or up 2, left 3, and there's my point of intersection. Right there. Now I just gotta name that point. And that is -3, -1. And that is our answer. Double check by plugging that point back into both equations. All right, number 3, solve by substitution. So first off, what makes this system a good one to do with substitution? It's the fact that this y is already isolated. So because the y is already isolated, I can just put a box around the other side. -2x minus 18. Where's this going to go? It's going to go replace the y in the other equation. So this other equation now becomes -6x plus 3 times parentheses -2x minus 18 equals 6. It's a very long equation, but it only has x's, therefore it can be solved. So how do I do that? I'm going to start by distributing in this 3. Now I've got -6x minus 6x minus 18 times 3, 54 equals 6. Combine like terms, add the 54 to both sides. -12x equals 60 divided by the -12. And I get x equals -5. So I found part of my answer, and I can reasonably guess that the correct answer is B, but I still have to plug this back in to solve for y. I'm going to go ahead and plug it right back into this equation here. So that gives me y equals -2 times x, but x has been replaced by -5, minus 18. y equals 10 minus 18, y equals negative 8. Now we can put these together into the ordered pair x comma y, negative 5 comma negative 8, and correctly pick B as our answer. All right, I'll leave number 4 for you guys to do. Let's look at number 5, solve the system by elimination. So what makes number 5, actually I'll leave number 5, that's the easier one. I'll do number 6. This one's still a very good candidate for elimination. It doesn't have a zero pair yet, but we can easily make one. So what I'm going to do is I'm just going to copy that top equation. So I'm going to say it times 1. I'm going to multiply this bottom equation so that I can get a zero pair with my x's. The zero pair of 6 is a negative 6. Negative 2 times 3 is a negative 6. So copying that first equation, 6x minus 7y equals negative 10. And then multiplying that bottom equation by 3. So negative 6x plus 3y equals negative 6. Now I can add the two equations together. The x's cancel out, and I'm left with negative 4y equals negative 16. Divide both sides by negative 4, and I get y equals 4. So it's looking like answer choice A, but we still got to plug it in and solve. I'll plug it into that bottom equation. So negative 2x plus 4 equals negative 2. Minus 4, negative 2x equals negative 6. Divide by negative 2, divide by negative 2. X equals 3. So 3 comma 4 is the correct answer. All right, backside. Some more solving by substitution. But number 7 really looks like elimination would be the better option, but it's telling us we have to do substitution. I'll change the directions. If you're watching this video, you can do number 7 by elimination. You'd have to deal with a whole bunch of fractions, but let's just see what happens. I add these together. These cancel out, these cancel out, these cancel out. They were all zero pairs, so I'm left with 0 equals 0. That's a true statement, so I have infinite solutions. Okay, take a guess. Well, I thought this would have no solutions, but I'm looking at it. It looks like that's probably not the case. Let's go ahead and solve 8. I'm going to do substitution. So I'll start with the 2x minus y equals negative 3 side. I'm going to add y to both sides and add 3 to both sides. So you get 2x plus 3 equals y. I'll box this side and plug it in for y right here. I get 7x minus 3 times 2x plus 3 equals negative 7. 7x minus 6x minus 9 equals negative 7. X minus 9 equals negative 7. Add 9 to both sides. X equals 2. Plug that back in. The easiest place to plug it in would be right there. 2 times 2 plus 3 equals y. 4 plus 3 equals y. Y equals 7. And we put that together into an ordered pair, 2 comma 7. I thought it was going to be a no solution since we just had infinite solutions, but this one has just a single solution. All right, let's get the solution to the system of inequalities. Here, I'll do one of these. Very similar to system of equations, but there's a twist here. So let's graph that first one. Point at negative 3. Slope is 4, so I'm going to go up 4, right 1, then up 4, right 1. But I don't just automatically connect it with a solid line. I have to look back at the inequality. This one doesn't have the or equal to, so this one gets connected with a dotted line. All right, and then this symbol here tells me to shade below that. So I'm shading below this dotted line, which is this half over here. Okay, next one, point at positive 3, down to right 1, down to right 1, down to right 1, down to right 1. Again, doesn't have the or equal to, so I pick a dotted line again. And this time it's saying shade above this line. So above this line would be this region up here, and we can see as I do that, one of these sections becomes darker. This section right here is the darkest. So we can go ahead and erase the sections where it didn't overlap and only keep that quadrant of these intersections highlighted. All right, so that means that any point in this region is going to make both of these equations or inequalities true. Any point exactly along the line will not do that. That's why they're dotted. All right, so try number 10, but watch out, there is the or equal to, so one of these will be dotted, one of these will be solid. All right, absolute value graphs. So what we do to graph these is we start with a point at the origin. But this point is going to stay, it's going to get moved, and this is how it's going to be moved. Any number at the end moves us up or down. This -2 here specifically moves us down 2. Any number being added, subtracted directly to the variable moves us left or right. This will specifically move us right 3. So it's worthwhile to memorize that this, when it's happening directly to the variable, it's often opposite of what you think. Minus sends you to the right, plus sends you to the left. Let me make that page look better. All right, so down 2, right 3, this is the new vertex. All right, now there's no coefficient in front, so we can say there's a 1 in front. That's the slope going to the right. So I add in that slope going to the right. All right, and then you have to mirror it. It makes a V-shaped graph. So if the slope was 1 over here, it's going to be -1 over here. And it's going to follow that diagonal all the way off the graph. And that is our absolute value graph. All right, let's try it one more time. So that is going to move us left 1. And this will move us up 3. So left 1, up 3. Here's our new vertex. This negative means there's a -1 in front. So our slope going to the right is -1. So slope of -1. And then we just have to make it symmetrical. All right, and there's our vertex right there of the V-shaped graph. Okay, call that good for this homework help video. Have a good rest of your day.